We're here at the Faulkes Telescope South and wanted to show you an example of a professional grade instrument. Many of the concepts that we learn in the astrophysics topic concern the use of a telescope like this. It's a 2-meter optical telescope, and the light from an object out in space comes down in through the telescope here, hits the mirror, is reflected up to a secondary mirror, and then down through the center of the primary mirror to all the instruments at the bottom of the telescope. So what I'd like to talk about first is sensitivity. Sensitivity is measured by the smallest signal that a telescope can measure, or how faint are the objects that a telescope can see. Sensitivity is very important in astronomy because many of the objects we look at are very faint. Now, one way to think about sensitivity is to think of a telescope like a bucket. Just like you put a bucket out in the rain to collect water, you put a telescope out under the night sky to collect light. So the bigger the bucket, the more water; the bigger the telescope, the more light you can collect. Now, the sensitivity of a telescope is proportional to the surface area of the mirror. So the bigger the mirror, the more light you can collect, the more sensitive your telescope is. So a telescope that has high sensitivity can see very faint objects. Another important concept in astronomy is resolution. When you're looking at an object through a telescope, there's a limit to how far apart two objects can be before they merge together, and you can't tell that they're two objects. So resolution is a really important thing to understand in astronomy. A telescope like this has a much better resolution than a smaller telescope. A telescope this size could resolve two objects 0.8 arcseconds apart, whereas a telescope this size can resolve two objects 0.06 arcseconds apart. So if there was two stars in a telescope the size of the bucket, those two stars may merge together like this. But in this telescope, we'll be able to see them clearly as two separate stars. There are other concepts in the astrophysics topic that relate to sensitivity and resolution. These are active optics, which work on this telescope to keep the optics aligned, therefore the resolution stays at its maximum. Adaptive optics, which compensates for the blurring effect of the atmosphere. And we also look at interferometry, which increases resolution by using several telescopes to get the resolution of a much larger telescope.